All right, so our next stop on the journey of one-dimensional kinematics is acceleration. You all probably have a good idea about what acceleration is, like when you're speeding up or slowing down. So the objective, students will describe motion in terms of changing velocity, in essence, acceleration. Students will compare and contrast graphical representations of accelerated and non-accelerated motions, and you will apply kinematic equations for constant acceleration. So you're going to know the distance equation, the time, and velocity. You find acceleration or any of those other three. So each time you take a step, you're changing the velocity of your body, whether you realize it or not. You're probably most familiar with velocity changes of a moving bus or car. Like anytime a car slams on the gas and you're pushed back in your seat, that force that's pushing you back there is caused by the acceleration of the car. Or anytime you slam on the brakes and you move forward, that motion is also caused by your changing velocity or your acceleration. So the rate at which velocity, speed or direction, actually be speed and direction, changes occur is called acceleration. So from a distance versus time graph, you see instead of being nice straight intervals, change the color here, so being nice straight lines covering the same distance in one time period, you see the amount of distance increases each time. So this means you're accelerating. So for a distance versus time graph, you get a nice curve instead. So acceleration, your change velocity over your change in time, or delta v over delta t. Change in velocity is represented by the final velocity minus your initial velocity. So here is another kinematics equation for you. Your average velocity equals your change in velocity over your change in time. Or sorry, your average acceleration equals change in velocity over change in time. Did I say that? I can't remember. So problem, a car traveling at 60 miles per hour accelerates to 90 miles per hour in 3 seconds. What is the car's acceleration? Anytime you do a problem in physics, it's probably going to be a word problem. You want to take all the information out of this problem before you begin. We call this inventorying. So we write down what we know. And for kinematics, you're going to write down these same things at the beginning of every problem. Fill it in, and you'll never get one of these guys wrong, I promise. So your initial velocity, what is your initial velocity? So a car traveling at 60 miles per hour accelerates. So must have been doing this one first. So 60 miles per hour. Accelerates to 90 miles per hour. This is our final velocity. 90 miles per hour. In a time of 3 seconds. So time equals 3 seconds. Acceleration. Do you know what it is? No, we don't, so we put a question mark. How far we went. Do we know how far we went? No, we're not. But we're only after the acceleration right now. But we can find this guy too. We need more equations though, which are coming at the end. Then, after you inventory, you want to write down what equation you're going to use to solve for your unknown. Then you're going to plug in the information from your inventory chart into your equation. So we know the final velocity was 90, we know the initial velocity was 60, we know the time was 3 seconds. You're going to carry out, simplify, until you get down to your answer. And always make sure you circle your answer. So 30 miles per hour per second. These units look kind of weird. But what they means is for every 1 second that passes, your velocity increases by 10 miles per hour. Another way to write this would be miles per hour per second. Now in physics, I said we like MKS units. So what do you think the MKS units for acceleration should be? We have miles, hours, seconds. We don't like miles. We do like meters. Instead of hours, we like seconds, MKS. Math kills students. Seconds are already in seconds. So meters per second, or a meter per second squared will be the MKS units for acceleration. So you can have a positive acceleration. You can see this is the speed versus time graph. So speed or velocity versus time. So this means in the first second, your speed increases from 0, starting from rest, to a speed of 20 meters, this is kilometers per hour, sorry, 20 kilometers per hour in a time of 1 second. So your acceleration for that first part will be 20 kmh over 1 second, or 20 kilometers per hour per second. Now the second little leg here, there to there, you increase your speed again by 20 kilometers per hour. But this time it took 2 seconds. So this time you get 10 kmh over second. Now we're going to do from here to here. You only increase your speed by 10 kilometers per hour. And it took you 4 seconds to do this. So you get 2.5 kmh over s. You can see it's increasing each time, but the rate at which it increases slows down. You can do the same thing, but for negative acceleration. Some people might refer to this as deceleration. It is kind of a misleading term. You're actually accelerating, but negatively. And I'll show you why on the next problem, why we don't use the word deceleration. So a car traveling at 60 miles per hour slams on the brakes. Oops, spelled brakes wrong. That's why I'm not an English teacher. Brakes to avoid hitting a deer. Car comes to a safe stop 6 seconds after applying the brakes. What is the car's acceleration? So we inventory. Initial velocity, 60 miles per hour. Final velocity. It doesn't actually give us a value for this, but it says the car comes to a stop. And how fast are we going if we're stopped? We're going 0. Time, 6 seconds. Acceleration, we don't know. How far we went, we also don't know. So we want to find the car's acceleration. Next step, we write down the equation we're going to use to find this acceleration. So this is your change in velocity over your time. Plug in what you know. We know the we know the final velocity is 0 miles per hour. We know the initial is 60. We know the time is 6 seconds. Carry out, simplify. 0 minus 60 is negative 60 over 6 seconds, or you get negative 10 miles per hour per second. Always circle your answer. This means for every second that goes by, we're slowing down by 10 miles per hour. It's negative. Now, if you said you were decelerating at negative 10 miles per hour per second, that'd actually be a double negative, and the deceleration would cancel out that negative. So if you choose to use the word deceleration, you have to get rid of this negative sign, which is why I don't like the word deceleration, and you should never use it in my class. So always just call it negative acceleration, please. So a constant acceleration produces a straight line or a linear slope. We remember what slope is? Rise over run. M, which is the mathematical symbol for slope. Rise, change in y, over a change in x. But if we look at our values on our x's and y axes, speed, so a change in speed or velocity over a time, a change in time. So the slope of a speed versus time graph gives us acceleration, delta v over delta t. And we can even see the units for this guy. We'll choose this point here and this point here just to make it easy on us. So our change in y, we ended at 8. We started at 4. Our time ended at 2, started at 1. So we get 4 over 1, which equals 4. But what are our units? Units on this are meters per second. Units on the time are seconds. So we get meters per second, or meters per second squared. Work. So the horizontal displacement, we kept putting a delta x on there. Sometimes you're going to have to find a delta x. Didn't ask you in any of these problems, but could definitely come up. But you can use a different kinematics equation to find this. And we call this one the distance equation, because distance is what we're solving for. Your delta x is what you're solving for. And to do this one, you have to know the initial velocity, you have to know the time, you have to know the acceleration, and time again. Or you can find the final velocity after a given time period of acceleration with this equation. So if we're looking for a final velocity and we're given the initial, the acceleration, and the time, you can find your final. Or sometimes you're given your final and you want to know how fast you started at. So you might have to rearrange this, use your algebra. Hopefully you remember your algebra. You're bone up on those skills. So final velocity can be calculated over horizontal displacement during acceleration without knowing the time. Some equations or some problems, we're not going to give you a time interval. And you're going to use this equation straight away. Pretty much anytime I give you a problem and it doesn't have time equals some amount of seconds or minutes or hours, you're going to use this equation. So your final velocity squared equals your initial velocity squared, plus 2 times the acceleration times how far you went. Now again, let's say I don't give you delta x, but I give you all these other things. You can rearrange this equation to solve for it. So in this case, like delta x will be equal to bf squared minus vi squared all over 2a. You can also find acceleration the same way. Replace your a with your delta x, like switch these guys.